Okay, so this is example 3.2, where we're going to introduce the idea of power and its relationship to work. A 15 kilowatt, this is pronounced kilowatt, electric motor provides the power for the elevator of a building. What is the minimum time needed for the elevator to rise 30 meters to the 6th floor when its total mass is loaded? The total mass loaded is 900 kilograms. Okay, so a lot of numbers in here. And the idea here is that power can be defined as the amount of work that's done. So in this case, done on the elevator, divided by the amount of time that it takes to do that work. So it's essentially a measure of how fast the energy is being used, how much work is being done over time. So P for power, we've been using W for work, and then we'll stay with T for time. Okay. So we already in the previous example learned how to calculate the amount of work for raising something against gravity, right? It's mgh. So we can just put in mgh for the amount of work and then divide that by time. Okay. So we can ask, do we have the mass? Well, yep, we do. It's 900 kilograms. Do we have the value of G? Yes, we know what G is. It's 9.8 meters per second squared. And do we have H? Yes, the height is given. It's 30 meters. So we've got everything we need for MGH. The question is, where's the power? Because we're asked for the time. Well, this is right here. It's providing power. So this is a measure of the power. So we would say that the power is very often measured in what we call kilowatts. This is called kilowatts because a watt is the unit, is a unit, it's the MKS standard unit for power. And a watt is a joule per second. So when we say that the motor is providing 15 kilowatts of power, what we mean is it's using 15 kilojoules of energy, or it's doing 15 kilojoules of work for every 1 second that it operates. Okay, so what we're going to do is we're going to take this equation, I'll write it again, P equals mgh over T, and we're just going to rearrange it to find T. If we multiply both sides by T, now T over T is 1, and that gives us T times P equals mgh. If we want to find T, now what we do is we divide both sides by P. And that gives us T on the left side, and then mgh divided by P on the right side of the equation. And that's what we'll use to calculate the amount of time. Now, there is one issue with this kilowatt. We will end up with kiloseconds if we just keep it as a kilowatt. So let's remind ourselves that kilo is 1,000, right? That's the meaning of that prefix. So when we say 15 kilowatts, really what we mean is 15,000 watts, right? Kilos 1,000, so 15,000 would be the power. That's our power, 15,000 watts. And again, a watt is a joule per second, okay? So that's fine. I'm going to put in joule per second for that. So let's put everything in here. We've got mass, which is 900 kilograms. We've got G, which is 9.8 meters per second squared. And then we've got H, which is 6th floor, so it's 30 meters. We're going to divide that by 15,000. Again, a watt is a joule per second, so 15,000 joules per second. Okay. Now, I am kind of running out of room over here, but if you take a look here, let's go through the arithmetic and then we'll look at the units differently. If you calculate this, what you're going to end up with is a little bit more than 17, a little bit under 18. It comes out to about 17.6, and that's our time. But we know the units should be seconds, right? Because this is time. So how do we get seconds out of here? Well, it doesn't look too simple except for the fact, remember from the previous problem, that a kilogram meter per second squared times a meter is the same thing as a joule. So this is really joules in the numerator and then joules divided by seconds in the denominator. So the joules cancel and you get 1 over seconds, which is just seconds. And there's your answer. So 17.6 seconds, between 17 and 18 seconds to move this elevator using that power, right? So think about it. If you had a more powerful motor, what would happen to the time? Right? Think about that. I'm going to put in a real powerful motor. What would happen is the P would be larger. More powerful means you have a larger amount of power. So if this power is greater, that's in the denominator, that's going to make the time smaller. And that should be intuitive, right? A more powerful motor will move the elevator faster. A weaker, less powerful motor will make it take longer to go up there. Okay, so 17.6. So with this one, you might want to review again that a kilogram meters squared per second squared is the same thing as a joule, which is the same thing as a Newton meter. And then a watt is equal to a joule divided by a second. It's the amount of work being done per unit time.